Math 1314, Tyler Junior College, Section 3.2, Polynomial Functions. Putting it all together. In other words, we're going to sketch a graph. I've got two examples planned. I want to do one that is not factored and one that is, to show you the differences between the two. Actually, more like to summarize the differences because we've seen both variations throughout this series of videos. So for example, we're going to sketch the graph of f of x equals 9x squared minus x to the fourth power by answering the following. A, the end behavior, B, y-intercepts, C, x-intercepts, and D, the intercept behavior. And I should say x-intercept behavior. In other words, we're going to analyze the multiplicities. So let's start by figuring out the end behavior. Now the end behavior should be pretty easy if you know where to look. Which term should we look at? Which is the leading term? If you said 9x squared, then I fooled you again, because the leading term is not determined by who's written first, but by who has the highest power. And the highest power is negative x to the fourth. So for the end behavior, we need to analyze a leading term of negative x to the fourth. So end behavior. The leading coefficient is negative, and the degree is even. What does this tell us? A negative leading coefficient tells us that it falls right, so the right end falls. Negative is falls, positive is rises. But what does it mean when the degree is even? That means that the end behaviors are equal, and so if it falls right, then it also falls left. And that's the complete analysis of the end behavior. Both ends fall. We'll summarize our results over here. Both ends fall. Let's find the y-intercept. Did you find it? Do you remember how to find it? For the y-intercept, you simply substitute 0 into the function. But because this is not factored, the first thing that happens to each 0 is a multiplication, and so everything disappears. We get 0 minus 0, which of course is 0. So our y-intercept is at y equals 0, or as an ordered pair, the origin. The x-intercept, however, will take some work. If your function is not factored, that means you have more work to do on the x-intercepts. And remember, for the x-intercepts, we have to solve the function equal to 0. So solve 9x squared minus x to the fourth is equal to 0. Let's get this factored. Greatest common factor. Everybody has some x's. More specifically, everybody has an x squared. So if I factor out an x squared, I get 9 minus x squared, which is a difference of squares. Some people would call it backwards. That's a matter of opinion. But remember, to factor a difference of squares, you unsquare each term, aka square root it. The square root of 9 is 3, so 3 times 3. The square root of x squared is x, if x is greater than or equal to 0, but let's not worry about that. One gets a plus, one gets a minus. Remember, we want to get it completely factored because part of the discussion we're having is about multiplicities, which are the powers on the factors. So if we solve the last factor equal to 0, we get x equals 3, because 3 minus 3 is 0. Well, let's go ahead and make note of its multiplicity with a capital M. Multiplicity is 1 because that's its power. What is the x-intercept? What is the 0 we get from 3 plus x? If we put 3 plus x equals to 0 and solve it, we'll get x equals negative 3, whose multiplicity is also 1. But what about x squared? Well, if we put x squared equal to 0, then all we would have to do is square root both sides and use a plus minus. But 0 is the only number that's equal to its negative, so the plus minus would be redundant, and we would just get x equals 0. But what's its multiplicity? The power that was on the factor that gave us this was 2. So now we have our x-intercepts. The first x-intercept, well, let's go from left to right. We have an x-intercept at x equals 0, or 0, 0, and its multiplicity was 2. we had an x-intercept at -3 or -3 comma 0, and the multiplicity was 1. And we had an x-intercept at x equals 3 or the point 3 comma 0, and its multiplicity was also 1. By the time we get to this point, the intercept behavior is actually just an immediate consequence of what we've just done. Because all we have to do is see whether the multiplicity is odd or even. There are two multiplicities that were that were odd. And remember, an odd multiplicity crosses the x-axis. So we know that we're going to cross the x-axis at -3 comma 0 and 3 comma 0. Both of those intercepts came from zeros that had odd multiplicities. But this x-intercept came from a 0 of even multiplicity, so that's where we're going to touch and turn at that x-intercept, which was 0 comma 0. It's a lot of analysis to do in advance just to sketch a graph by hand, and I will be the first to admit that there are technologies out there that will get this graph as soon as you type that in. One such technology is a free website called Desmos.com, DESMOS.com. It's a free online graphing calculator. It's very intuitive to use, and it's a nice way to check your results. But I'm not teaching you just how to press buttons on a keyboard or scan a picture to get a graph. I'm teaching you to analyze and think. Anybody can do algebra by taking a picture or typing something into a computer, but it doesn't make them a lick smarter. It doesn't improve their brain cells any. By doing the math manually, mentally, without the aid of technology, you are literally firing neurons in parts of your brains that aren't normally firing. That strengthens the synapses in your brain. Basically, it makes your brain work better, more efficiently, more analytically. So if you get anything from college algebra, it should be, my brain works better. I'll get off my soapbox now. Okay, so here's all the information we know about this graph. Let's see how easily we can sketch it. Let's start with the end behavior. To represent both ends falling, I'm going to draw an arrow pointing down on the left and on the right. And that doesn't mean I'm going to connect them to make the graph. Those are just visual reminders that both ends will fall. We have a y-intercept at 0, so we'll put a dot here. We have an x-intercept at -3 and +3, so back 3 and to the right 3. To represent the intercept behavior at the multiplicities, at the x-intercepts, I'm going to put either a lowercase c for cross, or capital C for cross, or a capital T for touch and turn. For example, back at -3, we cross the x-axis, so I'm going to put a capital C there just to say cross. Also at +3, we cross the x-axis, but at 0, we touch and turn. And now I'm ready to draw a rough sketch. I need to start low, cross here, touch and turn here, cross here, and end low. Here we go. Start low, cross here. Now in order to come down here to touch and turn, I need to hit a maximum, if you will. I need to switch from increasing to decreasing. If you're worried about where do we turn around and how high is it when we turn around, those technically are calculus issues that without technology we can't readily get answers to. In calculus, you will learn how to do that if you're going that far. Of course, technology can also locate the high and low points. Desmos.com, you can click a high or low point. It'll tell you its approximate coordinates. But for our purposes, all we know is that after we cross here, we're going to have to turn around somewhere to touch and turn. Where is irrelevant for our purposes. Now, as I'm coming down towards this x-intercept at 0, I got to remember that I'm going to touch and turn. When you touch and turn, it almost looks like you flatten out just for the briefest of moments. You don't actually flatten out, but it looks like you do. And now I'm gonna have to cross this, which means I have to go up, I have to go up and turn around somewhere. How high, where are questions we can't answer without calculus or technology. So we'll just go up somewhere. This does everything I said it needed to do. Opens fall, correct y-intercept, correct x-intercepts, crosses where it's supposed to, touches and turns. As far as the maximums and minimums, well, this minimum we know because it touched and turned. But the maximums without calculus, we couldn't locate them precisely, so we could just freehand it. There are some online homework questions and some professors that will also ask you in this list of things to do, is this an even or odd function? I left it out because sometimes that's not as easy to answer, although in this case it would be. This would have been an even function, which means it would have had y-axis symmetry, which is why I know that these are going to peak at the same point, or at the same height, I should say.